everyone. In this video, we are going to concentrate on learning to draw Lewis structures with double and triple bonds, and we're going to do a polyatomic ion bond as well. So let's go ahead and get started. I'm going to switch over to the dry erase board and we can begin. You do want to have a periodic table nearby. It will probably be very useful to you in figuring out your valence electrons, unless you have them pretty well memorized, okay? The first one that we're going to do is carbon dioxide. So carbon dioxide, let's make our list of elements. We have C and O. There is one carbon, two oxygen. Our next step is to multiply times the valence electrons. Carbon is in group 14, so it will have 4. 1 times 4 is 4. Oxygen is in group 16, so it will have 6. 2 times 6 is 12. If we add it together, we have 16 electrons that we must draw. So now we need to draw it. We know that carbon is going to go in the middle because there's only one. And we do like to keep things symmetrical, so we're going to have an oxygen on each side. Okay, so right now everything is hanging out, so we need to draw a single bond to connect them. Remember, each line is 2, so 2 and 2 is 4. We've already used 4, so that means we have 12 left. So since there's 12 left, we're going to go ahead and distribute them evenly. We're going to put 6 on each oxygen. Okay, so we used all 12, which is awesome. Okay, so we used all 12 electrons. Now oxygen is happy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So each oxygen is happy, but carbon is not. Carbon only has 4. 2 plus 2 is 4. So since carbon is not happy, one of the oxygens is like, you know what? Hey, I'm going to share 2 of my electrons with you, and we create a double bond. So we created a double bond. So this is another line. So it is another 2 electrons. When you do create a double bond, you still like to keep things symmetrical, which is why we took it from out here, because the top and the bottom are still the same. So let's count again. This oxygen still has 8. 1, 2, 3, 4, 5, 6, 7, 8. This carbon now has 6. 2, 4, 6. So carbon is still not happy. This oxygen goes, hey, if he can do it, I can do it as well. So we're going to take 2 of those electrons from the outside and create a double bond as well. So now each oxygen is happy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the carbons are happy too. 2, 4, 6, 8. So now everybody is happy and it has 8. And there are 2 sets of double bonds. 1, 2. Okay. All right, let's do another one together. Okay, we have SO3. Okay, so we're going to make our list of elements and valence electrons. We have S, we have O, there is one S, there are 3 O's, and we're going to multiply times our valence electrons. S is in group 16, so it has 6. 1 times 6 is 6. Oxygen is also in group 16, so it too has 6. 3 times 6 is 18. 6 plus 18 is 24. Okay? So now we have to go ahead and draw it. What's going to go in the middle? Since there's only one S, S is going to be the one that goes in the middle, and we're going to have an O on the top, an O on each side. Okay? First thing is we need to connect them with our single bonds. Each bond is 2, so that's 2, 4, 6. And we have 18. So we can evenly distribute those 18 amongst all 3 of those oxygen. 18 divided by 3 will give us our 6. Okay, so now each and every oxygen is now happy. Every oxygen has 8. 1, 2, 3, 4, 5, 6, 7, 8. And same with each of the other ones. Sulfur, though, only has 6. All right, Sulfur is one of those exceptions to the rule. Sulfur is actually happy with 12. So each oxygen is going to donate 2 to create double bonds. Okay, so every oxygen donated 2 to create a double bond. Now every oxygen is still happy. 1, 2, 3, 4, 5, 6, 7, 8. And that's the same with each oxygen. And now sulfur is happy as well. 2, 4, 6, 8, 10, 12. Sulfur is one of those exceptions to the octet rule. It is happy with 12. Okay? So that's our double bonds. One thing to keep in mind about double bonds is you cannot double bond until you have used all of these up. So you cannot create double bonds until this number gets to 0. All right, so you must use all the electrons before you start double bonding and triple bonding. Okay? All right, let's try a triple bond together. Okay? All right, so let's do a triple bond together. We're going to do N2. We have N. There's 2 of them. We're going to multiply times the valence electron. Nitrogen is in group 15, so it has 5. 2 times 5 is 10. So since there's 2 nitrogens, they're going to go next to each other. Okay? We are going to connect them with a single bond. That's 2. So there's only 8 left. Since there's 8 left and 2 nitrogens, let's put 2 on each side. Okay? Or we're going to put 4 on each side. My apologies. We're going to distribute them evenly. We're going to put 4 on each side. So we now have used them all up. Neither nitrogen is happy. No one's happy, so we have to start double bonding. This nitrogen says, all right, I'll donate 2 to you. So we take those 2 electrons out. We create a double bond. Now, this nitrogen has 1, 2, 3, 4, 5, 6. This nitrogen is happy. 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen, though, feels bad because his brother is not happy. So this nitrogen says, if he donated 2, then I can donate 2, and takes off 2 electrons, and we create a triple bond. Now, each nitrogen is happy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now we have happy, we have a triple bond. If we want to draw it nice and neat, it would look something like this. So everything is nice and symmetrical. Okay? So we just did triple bonds. I'm going to do one more with you, and we're going to do a polyatomic ion. Okay? Okay, so we are going to do NO3 minus 1. Since this negative 1 is there, it does come into play, okay? We are going to start the same way. We're going to make our list. We have N, we have O, there is 1 N, there are 3 O's. We're going to multiply times our valence electron. Nitrogen is in group 15, so it's 5. 1 times 5 is 5. Oxygen is in group 16, so 3 times 6 is 18. We're going to add them together. 5 plus 18 is 23. Now this is where our negative number comes into hand or comes into play. Since this is a negative 1, we're actually going to add 1 more down there to get 24. Remember, if something has a negative sign, that means it actually gained electrons, so we actually have to add 1 more to this, okay? If it was a positive sign, you would subtract 1, okay? So now we can go ahead and draw it in the same way. We know that N is going to go in the middle because there's only 1. We have 3 O's, okay? We're going to connect them with our single bonds. Each bond is 2, so 2, 4, 6. That means we have 18 left. So each O is going to get 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we have now used all 18. Okay, so since we have used 18, our oxygens are happy, but our nitrogen is not. So one of the oxygens, it does not matter which one, is going to share to create a double bond. So I'm just going to take it off this one, and we're going to create a double bond. So right now, nitrogen is happy. It's 2, 4, 6, 8, and this oxygen is also happy. It does not matter which oxygen you form a double bond with. This is called a resonance structure. You could draw it 3 different ways with each of the oxygens. Now, our last step, since this is a polyatomic ion, is to put it in brackets and write the charge with a -1. This will show that it was a polyatomic ion, okay? So once again, the best way to get better at drawing double, triple bonds and polyatomic ions is to practice, practice, and practice. If you have any questions, please feel free to reach out.